Welcome to the AirPulse Challenge. In this video, I'll walk you through what the challenge looks like in a classroom, how you can run it with your students, and how it connects to the larger competition. At its core, the AirPulse Challenge is simply an engineering and design competition where students build small cars powered by an air compressor. More importantly, it's a hands-on way to teach the design process. Students will design, build, test, fail, redesign, and repeat over and over again until they get something that they like. No matter which version of the challenge you run, this is the ultimate battle against friction. Students will be working to reduce friction between the car and the track surface, the axles, and air resistance on the body, friction from the air hose connection, and friction between the car and the guide wire. Every design decision they make connects back to performance. This is one of the most effective design challenges you can run because students care about their car. By day 5, one student races and another student loses. Immediately, things begin. What can I do to make my car faster? They modify or they rebuild the entire car. They race again, they test again, they iterate again and again and again. Because material costs are so low on this project, students can build multiple versions of the car, often 2, 3, or 4 designs. And because it's powered by compressed air, testing is fast, repeatable, and doesn't cost a thing. This creates a true iteration cycle, similarly to what they'd see in industry. In fact, I often tell students if they think their first car is perfect, build a second car anyways. Just like a Formula One team, you always have a backup, and the second car often tends to be faster. One of the strengths of this challenge is the flexibility. You can run it with different tools and different skill levels. Option 1 is if you're in a shop situation where you have access to tools like a bandsaw, drill press, and other hand tools. Students will sketch hand-drawn or simple CAD. They can build the first prototype in typically 5 classes, then rapidly iterate, rebuild in 1 to 2 classes. This is the most accessible version and works extremely well with grade 9s and 10s. Another option is the 3D printed entry point. For classes using CAD and 3D printing, students design digitally, print prototypes, test, and refine. Some considerations though, students, this should not be their first CAD project that they work on. Print times can be a bottleneck, and the iteration cycle may be slower because of the print times. Third option, I call this a hybrid, and this is for mostly your senior classes. Students combine wood, foam, plastic, laser cut parts, 3D printed parts, basically anything they've done in design from grade 9 through to the senior programs is at their disposal. These cars are larger, a little more complex, which introduces more surface friction challenges, more creative design opportunities, longer build and redesign cycles. Students often test smaller components first and then commit to a full rebuild. The launcher. You can build a simple launcher for under $30. In this example, we have an air tool handle, basic fittings from Home Depot, and a few 3D printed parts. We'll provide the parts list and the instructions on the website. For the track, you don't need anything special. A hallway or gym works perfectly. Length, we run 10 meters, but you can scale based on your space. Each lane uses a fishing line as a guide. Cars are tethered and run along the line. Lanes are anchored at both ends to keep the cars straight. We typically operate around 90 psi, but have gone up to 110 psi for some of the larger cars. Timing in your classroom, typically this takes 2 to 3 weeks. Week 1 is design and build. 2 is testing and iteration. Week 3 is refine, compete, and reflect. At the end of your in-class tournament or competition, however you run your final part of this unit, we usually have students go head-to-head and work in some sort of tournament bracket system. Students would submit their cars, their design sketches, files, and a written or a video of the process of what they did to get from their original design to their final design. To select your school team, this would extend what you've done in class. Our suggestion, and you may do whatever you choose, but possibly take your top 4 cars, have those students combine a school team where they analyze each other's design, collaborate together to build an even faster car. The competition that we run here is a full day event. Students will participate in 4 different components. There'll be a poster presentation, which will visually display their designs, and it'll be a backdrop for their pit area. There'll be an oral presentation, which explains the design process that they went through, the challenges and the improvements they made. There will be a technical inspection to ensure the car meets all specs of the competition. And of course, the big part is the racing. There will be time trials to seed cars, and then we'll go through a bracketed race to determine final standings. So even if you've never run a design challenge like this before, this project is highly forgiving. Students quickly take ownership, they troubleshoot, they work independently, they work with each other, and they push themselves because they want to win. Your role as a teacher becomes less about directing and more about guiding the process. If you have any questions, please reach out to us at Longfield Stapleton Heights, and we hope you're able to join us on June 5th.